Welcome to our next lesson on volume by cylindrical shells. So a cylindrical shell with inner radius r sub 1, outer radius r sub 2, and height h. And you could see that going on in our picture on here. We have r sub 1 for that inner radius, r sub 2 for the outer radius up to that outer portion of the shell, and then h is the height. So the volume V would be the volume for the outer shape minus the volume for the inner shape in order for us to get this small shell around this area. And this would be 2 pi times r sub 2 plus r sub 1 divided by 2 times h times r sub 2 minus r sub 1. So if we let delta r be r sub 2 minus r sub 1, this would be the thickness of the shell, which you could see being shown on here as this small portion of that shell. And r is a half times r sub 2 plus r sub 1, so the average radius. You could see that being shown on here on our graph. The volume formula can then be reduced to V is equal to 2 pi times r times h times delta r. So if we let S be the solid obtained by the y-axis, the region bounded by y is equal to f of x is greater than or equal to 0, y is equal to 0, x is equal to a, and x is equal to b. So we are taking this particular solid, this particular area here, and rotating it around this y-axis in order to obtain this particular solid, as we show here on this graph to the right, in the upper right-hand corner. So we're going to divide our interval, our closed interval, from A to B, into n subintervals, x sub I minus 1, comma x sub I, of equal width, which is delta x, and let x sub I bar be the midpoint of the ith subinterval. So if the rectangle with base x sub I minus 1, comma x sub I, and height f of x sub I bar is rotated about the y-axis, we obtain a cylindrical shell with average radius x sub I bar, height f of x sub I bar, and thickness delta x. Its volume v sub I is 2 pi times x sub I bar times f of x sub I bar times delta x. So we have here the circumference. This is the height. And this is the thickness. So circumference, C, height, and thickness. So the best approximation for this volume takes the limit as n approaches infinity of the sum from I is equal to 1, that is half cut off the page here. I is equal to 1 to n of 2 pi times x sub I bar times f of x sub I bar times delta x. And you can see that going on in our pictures here, where we have that ith rectangle, and it's shown it being rotated about that y-axis to then give us our solid that we need to find the volume of. So this method of cylindrical shells then is the volume of the solid, as previously described on that last slide, obtained by rotating about the y-axis, the region under the curve y is equal to f of x from A to B would be v is equal to the integral from A to B of 2 pi x times f of x dx, where A is between 0, including 0, and B, but not including B. And you can kind of see that going on where we take this solid that we have and we kind of fold it out to see that we have our circumference, 2 pi x, delta x is our thickness again, and f of x is our height, as we could see in our 3D model. So for example, we want to find the volume of the solid obtained by rotating about the y-axis, the region bounded by y is equal to 2x squared minus x cubed, and y is equal to 0. And you can see this red curve is that y is equal to 2x squared minus x cubed. So based upon this shell method that we are seeing here, this will be v is equal to the integral from 0 to 2 of 2 pi x times 2 times x squared minus x cubed dx. And the reason for why it goes from 0 to 2 is because we would need to solve this. 2x squared minus x cubed is equal to 0. So you could factor out that x squared times 2 minus x to be equal to 0, which is where we got the x is equal to 0 and x is equal to 2 from, respectively. So before doing this, we can simplify this a bit. We could take out the 2 pi from that integral. So 2 pi times the integral from 0 to 2 of, we can multiply the remaining x times 2x squared minus x cubed to make 2 times x cubed minus x to the 4th dx. So this would be 2 pi times, this would be a half times x to the 4th minus a 5th times x to the 5th. Evaluate between 0 and 2. If you put 0 into this, you get 0 back anyway. But if you put 2 in, you get 2 pi times 8 minus 32 fifths. As a fraction, this makes 16 fifths pi. So that is the end of part 1 of our lesson here on the volume by cylindrical shells. Be on the lookout for part 2. Thank you.